Let's see if we can take some systems of equations, two equations and two variables, and set them up so we can start solving them using these augmented matrices. I don't want to solve the whole problem for you, but let's see if we can't set some of these up. So remember, here's our elementary row operations. Here's our goal for a 2-by-2 system once we get it in the matrix form. This is what we want, this 0 right here. Okay, let's start with this system right here, and I'll represent it with an augmented matrix, which will be 1, 1, and 5. Those are the coefficients and the constant terms, just getting rid of the variables. Here, 3, negative 1, 3. So 3, negative 1, 3, right? Okay, so now I want to get a 0 in this position right here. So what's going to do that for me? And all I can use is these things right here. Well, I could take row 1 and what? Multiply by negative 3, add to row 2. I'm going to get a 0 right here. That's the thing to do. So I'm going to say this. Let's take negative 3 times row 1, add it to row 2, and then replace row 2 with that. So I'm going to take negative 3 times row 1, add it to row 2. So the important part of this is that these two things right here match. You can't multiply negative 3 times row 1, add it to row 2, and then replace row 1 with that. You can only multiply, take a constant multiple of one row and add it to another row. That row that you add it to, you haven't multiplied that row by anything. So here's my suggestion for how to start that system right there. How about this? 2x minus y equals 4, x plus 3y is equal to 9. Let's write that as in matrix form. How about 2, negative 1, 4 for the constant term, and then 1, 3, and 9. Okay, I look at this, I don't know what to do unless I'm thinking of this goal right here. And I don't know how to go about it unless I'm thinking of these rules right here. So I want a 0 in this position right here, and I have to use these things to do that. How about if we start by, well, we could multiply this row by 1/2 or negative 1/2 and add it to this, because negative 1/2 times 2 is negative 1, plus 1, I'd be okay, but maybe I'd have to work with fractions over here. How about if we just take this and take row 1 and interchange it with row 2? And so if I do that, then I have 1, 3, 9. The second row becomes the first row, and then 2, negative 1, 4. Now, I want a 0 right here. How about negative 2 times this row, add it to this row? That'll work, and then you're okay after that. Okay, let's go over to this system. I'll write my matrix. 2, negative 8, 6. All right. So, and how about 3, negative 8, 13? Don't let these two negative 8s confuse you. We still have the same goal, and that's a 0 right here. That's what we want to do. Okay, so let's see. What's an idea that I could do? I can't get a 1 in either one of those places real easily by interchanging two rows. I could take this row right here and multiply it by negative 3/2. Negative 3/2 times 2 will be negative 3. And if I add it to this row, I'll end up with 0. But people don't usually like to work with fractions that much. How about if I take this first row right here and just multiply it by a 1/2, so I get a 1 in that position. So how about 1/2 times row 1 becomes row 1. Okay, if I do that, what have I got here? 1. 1/2 times 2 is 1. 1/2 times negative 8, negative 4. Luckily, these are all even numbers. 1/2 times 6. 1/2 times 6 will be 3. And then I didn't do anything to the second row, so 3, negative 8, 13. Well, now I know what to do, right? Negative 3 times row 1 added to row 2, I'll have a 0 right there. Once I have that 0 right there, I'm done. I translate back into a system of equations that turns out to be easier to solve usually than the first one. So that's just a look at setting up 3 systems of equations using matrices. You can finish the solutions yourself.